Good day, learners! Welcome to Learn by Video series on General Mathematics. This is brought to you by QuexHub Smart Mobile Learning. In this video, we're going to have introductions to functions. I am Engineer Rex Jason H. Agustin. I am a board passer of the October 2009 Electronics Engineering Board exam, and I am also the 9th placer in the March 2015 Licensure Examination for Teachers major in Mathematics. In this General Mathematics video series for grade 11 senior high school students, we are going to discuss these following topics. This is based on the Department of Education's curriculum. Part 1, Function and their graphs, Introduction to Functions, Rational Functions, Inverse Functions, Exponential Functions, Logarithmic Functions. Part 2, Basic Business Mathematics, Simple and Compound Interest, Simple and General Annuities, Basic Concepts of Stocks and Bonds, Business and Consumer Loans. Part 3, Logic, Propositions, Tautologies and Fallacies, and Syllogisms. At the end of this series, we should be able to put a check in these boxes. But in this particular video, we are just going to focus on Introduction to Functions. Our discussion will be based on the most essential learning competencies given by the Department of Education. That's why we are really hoping that this series will really help you a lot in your studies. So please grab a pen and paper so we can now get started. Our target most essential learning competency on this video is representing real-life situations using functions, including piecewise functions. Our topic outline would be, first, relations and functions, next, the vertical line test, and then the piecewise functions. In line with the most essential learning competency, our learning objectives would be to define functions and relations, to identify graphs of functions through vertical line tests, and to give real-life examples where we use functions, including piecewise functions. Let us now start with the definition of terms. Relation. A relation is a rule that relates values from a set of values called the domain to a second set of values called the range. Function. A function is a relation where each element in the domain is related to only one value in the range by some rule. It says here that a function is a relation. We can say that all functions are relations, but not all relations are functions. Okay? We can also think of a function as a machine that is labeled f of x or function of x. Again, this is read as f of x or function of x and not f times x. Okay? But we should not also limit ourselves in using letter f. We could also label function as g of x, h of x, or whatever letter you want. Just like any other machine, a function can accept input and turn them into output. In function, the inputs are called domain and the outputs are called range. Okay. Domain and range. Domain. The domain of a function is the complete set of possible values of the independent variable, usually x. Range. The range of a function is the complete set of all possible resulting values of the dependent variable, usually y, after we have substituted the domain. Again, the domain is the set of values for our independent variable, or our input. Range is the set of possible values for our dependent variable, or our output. Representations of functions and relations. We can represent functions and relations in many different ways. We can represent them using set of ordered pairs, table of values, mapping diagram, graph, or equations. Let us have an example. Example number 1. Identify the domain and range of 2, -3, 4, 6, 3, -1, 6, 6, and 2, 3. In this given set of ordered pairs, the domain would be 2, 3, 4, 6. These are the x values. We have 2, 4, 3, 6, 2. We just have them here arranged in ascending order. For the range, it would be -3, -1, 3, and 6. These are the y values. We have -3, 6, -1, 6, and 3. Again, we just have them here arranged in ascending order. Okay? Example number 2. Which of the following relations are functions? Letter A, f equals -5, 2, 0, 4, 1, 5, 4, 4. Letter B, g equals -3, 2, 2, 2, 3, 3, 2, 0. Letter C, h equals 1, 3, 2, 6, 3, 9, and so on until n, 3n. For us to be able to determine which among these relations are functions, we should go back to the definition of a function. A function is a relation wherein each element in the domain is related to only one value in the range by some rule. Again, each element in the domain is related to only one value in the range. So for letter A, f equals -5, 2, 0, 4, 1, 5, 4, 4, we can see that for each value of x, there is only one unique corresponding value of y. Thus, it is a function. But for letter B, g equals -3, 2, 2, 2, 3, 3, 2, 0, we can see that the x value 2 corresponds to two y values, 2 and 0. We have here ordered pair 2, 2 and 2, 0. We have only one value of x, 2, but it corresponds to 2 and 0. Thus, it is not a function. For letter C, h equals 1, 3, 2, 6, 3, 9, and so on until n, 3n, we can see that each x value corresponds to a unique value of y. Thus, it is a function. Okay? Example number 3. Which of the following mapping diagrams represents a function? For mapping diagram A, we have in the first set x values, and in the other set, we have y values. X equals 4 corresponds to y equals 1 and y equals 3. X equals 5 corresponds to y equals 2, and x equals 6 corresponds to y equals 3. Since x equals 4 corresponds to two values of y, this mapping diagram does not represent a function. Not a function. For mapping diagram B, in the first set, we have names, and in the other set, we have ages. Asher corresponds to age of 2, Liam corresponds to age of 6, Yuri and Leona both correspond to age of 9. Since each name here corresponds to only one age on the other set, this mapping diagram represents a function. Mapping diagram B represents a function. For mapping diagram C, in the first set, we have here time, and on the other set, we have sport events. 1 p.m. corresponds to volleyball event, 2 p.m. corresponds to soccer event, and 4 p.m. corresponds to both chess and basketball events. Since the time 4 p.m. corresponds to two sport events, this mapping diagram does not represent a function. Mapping diagram C does not represent a function. Example number 4. Determine which of the following equations are functions and which are not functions. A. Y equals 2x cubed. B. Y equals x squared minus 1. C. Y squared equals x plus 9. Let's take a look at them one by one. Letter A. Y equals 2x cubed. For us to be able to know whether this is a function or not, we should first set up a table of values for y equals 2x cubed. We're going to let x be equal to -2, -1, 0, 1, and 2. Note that we can use any value for x. You can change this from -3 to +3 or from -5 to +5. But for now, let us just use -2 to +2. Substituting -2 to x gives us y equals 2 times -2 cubed, which is equal to -16. Substituting -1 to x gives us y equals 2 times -1 cubed, which is equal to -2. Substituting 0 to x gives us y equals 2 times 0 cubed, which is equal to 0. And substituting 1 to x gives us y equals 2 times 1 cubed, which is equal to 2. And substituting 2 to x gives us y equals 2 times 2 cubed, which is equal to +16. We can see that for every x value, there is only one corresponding value for y. Thus, y equals 2x cubed is a function. Each value of x corresponds to only one value of y. Thus, this is a function. Letter B. Y equals x squared minus 1. Again, to determine if this is a function or not, we should set up a table of values for y equals x squared minus 1. Note that we can use any value for x, but in this case, we're going to let x be equal to -2, -1, 0, 1, and 2. Substituting -2 to x will give us y equals -2 squared minus 1, which is equal to 3. Substituting -1 to x will give us y equals -1 squared minus 1, which is equal to 0. Substituting 0 to x will give us y equals 0 squared minus 1, which is equal to -1. Substituting 1 to x will give us y equals 1 squared minus 1, which is equal to 0. And substituting 2 to x will give us y equals 2 squared minus 1 equals 3. Again, for every x value that we substitute in this equation, there's only one corresponding output for y. Thus, it is a function. Each value of x corresponds to only one value of y. It is a function. Letter C. Y squared equals x plus 9. To determine whether this is a function or not, we're going to set up a table of values for y is equal to square root of x plus 9. note that y squared equals x plus 9 can be written as y equals square root of x plus 9. Alright? Okay, let's let x be equal to negative 2 to positive 2. Again, you may use any value of x. You can change this if you want. But let's stick to the x values negative 2 to positive 2. Substituting negative 2 to x will give us y equals square root of negative 2 plus 9, which is equal to square root of 7 and negative square root of 7. Okay? We should remember that the answer for a square root yields to two answers, positive and negative. Okay? Substituting negative 1 to x will give us y equals square root of negative 1 plus 9, which is equal to positive square root of 8 and negative square root of 8. Substituting 0 to x will give us y equals square root of 0 plus 9, which is equal to positive 3 and negative 3. Substituting 1 to x will give us square root of 1 plus 9, which is equal to positive square root of 10 and negative square root of 10. And substituting 2 to x will give us square root of 2 plus 9, which is equal to positive square root of 11 and negative square root of 11. In this table of values, we can see that for every x that we are substituting in this equation will yield to two answers for y. Thus, it is not a function. Each value of x corresponds to more than one value of y. This is not a function. Okay? So for our example number 4, letter A, y equals 2x cubed. It is a function. Letter B, y equals x squared minus 1. It is also a function. And letter C, y squared equals x plus 9 is not a function. Alright. Next, we have vertical line test. A vertical line test is a visual way to determine if a curve is a graph of a function or not. The curve is a graph of a function if the vertical line intersects the graph at exactly one point only. Let us show some examples of graphs of equations representing functions of x. We have here a graph for y equals absolute value of x. If we are going to draw a vertical line and then move this vertical line from left to right, we can see that the vertical line intersects the curve at only one point at any instant. This is a graph representing a function. Another one, we have here a graph for y equals 2x. It's a line with a slope of positive 2. If we are going to draw a vertical line and then move this line from left to right, we can also see that the vertical line intersects the curve at only one point at any instant. This is a graph representing a function. Now let us have some examples of graphs of equations not representing function of x. We have here the graph for x squared plus y squared equals 4. This is a graph of a circle with center at 0, 0 and radius equal to 2. If we are going to draw a vertical line and then move this vertical line from left to right, we can see that there are instances that this vertical line intersects the curve at 2 points. This is a graph not representing functions of x. Another one, we have here a graph for x equals the absolute value of y. If we are going to draw a vertical line and then move this line from left to right, we can also see that there are instances that the vertical line intersects the curve at 2 points. This is a graph of equation not representing functions of x. Let us have example number 5. Determine whether the following graphs represent functions of x or not. We have graphs A, B, and C. Graph A is a graph for y squared is equal to x plus 4. Let's draw a vertical line and then move it from left to right. We can see that there are instances that the vertical line intersects the curve at 2 points. Thus, the graph does not represent a function of x. Graph B. It's a graph for y equals 5 sine x. Again, let's draw a vertical line and then move this vertical line from left to right. We can see that the vertical line intersects the curve at only 1 point at any instant. Thus, this graph represents a function of x. Graph C is a graph for y squared minus x squared equals 2. If we are going to draw a vertical line and then move it from left to right, we can see that there are instances that the vertical line intersects the curve at 2 points. So, this graph does not represent a function of x. Okay? Let us have some real-life examples of functions. Example number 1. For each donut in a store, there is only one corresponding price. Say, for example, this donut costs 30 pesos. We can say that the total cost on donuts is a function of the price and the number of donuts x. We can write a function c of x is equal to 30 times x. C of x refers to the total cost and x refers to the number of donuts. If we are to buy 2 pieces of donuts, we have to pay 30 times 2 or 60 pesos. And if we are going to buy 10 pieces of donuts, we have to pay 30 times 10 or 300 pesos. Example number 2. For each car in a country, there is only one corresponding plate number. This car, for example, can only have one assigned plate number. There are no 2 cars in the country having the same plate number. Thus, we can say that the number of car plates is a function of the number of cars in the country x. We can write a function n of x is equal to x. N of x is the total number of car plates and x is the number of cars. Example number 3. For each person, there is only one corresponding age at any given time. Say, for example, this man is 18 years old today. No person can claim that he or she is both 18 years old and 60 years old at the same time. That is impossible. We can say that age is a function of time, t, and we can write a of t is equal to t, where a of t is the age. Let us now go to piecewise function. A piecewise function is one which is defined not by a single equation, but by 2 or more. Each equation is valid for some interval. For example, a piecewise function is given by f of x is equal to x plus 4 if x is greater than or equal to 4. F of x is equal to x minus 2 if x is less than 4. One equation gives the values of f of x when x is greater than or equal to 4, and the other equation gives the values of f of x when x is less than 4. Let us have example number 6. A jeepney ride costs 9 pesos for the first 4 kilometers, and each additional integer kilometer adds 1 peso and 50 cents to the fare. Use a piecewise function to represent the jeepney fare in terms of distance d kilometers. That would have to be f of d is equal to 9 if d is less than or equal to 4, and f of d is equal to 9 plus 1.5 times quantity d minus 4 if d is greater than 4. Okay? Example number 7. A user is charged 300 pesos monthly for a particular mobile plan, which includes 500 free text messages. Messages in excess of 500 are charged 1 peso each. Represent the monthly cost for text messaging using the function c of x, where x is the number of messages sent in a month. That would be c of x is equal to 300 if x is less than or equal to 500. C of x is equal to 300 plus x minus 500 if x is greater than 500. Okay? Example number 8. Write the equation for the piecewise function whose graph is shown. So we need to write an equation for this graph, and that would have to be y equals 1 if x is greater than or equal to 0 but less than 2. That is for this part of the graph. Y equals 1, and it stretches from x equals 0 to x equals 2. The shaded dot here tells us that it includes x equals 0, and the hollow dot here tells us that x equals 2 is actually not included. Y equals 3 if x is greater than or equal to 2 but less than 4. That is for this part of the graph. Okay, you have 1, 2, 3, y equals 3, and it stretches from x equals 2 to x equals 4. Okay, the shaded dot here tells us that x equals 2 is included, and the hollow dot here tells us that x equals 4 is actually not included. Then y equals 5 if x is greater than or equal to 4 but less than 6. That is for this part of the graph. We have 1, 2, 3, 4, 5. Y equals 5. And it stretches from x equals 4 up to x equals 6. The shaded dot tells us that x equals 4 is included, and the hollow dot tells us that x equals 6 is actually not included. Okay? Now let's check what have we learned so far. In this video, we were able to define functions and relations. We were able to identify graphs of functions through vertical line tests. And we were also able to give real-life examples where we use functions including piecewise functions. In our next video, still under the topic Introduction to Functions, we are going to focus on evaluation of functions. For more related practice problems, you may use our QuexBook General Mathematics app available from Google Play Store and Answer Chapter 1.